Swayam Prabha. Digital India. Educated India.
Okay, students. Last time I taught you the strategies of the different pre-treatment method and enhancement activity, deactivations by different methods. Let's continue this topic, and I will complete this with some basic informations and some advanced level for this all the treatment applications for the sensor development. So, the tuning of the electrocatalytic activities that can be done by different way. So, I taught you like different tuning method, like one tuning is the chemical, second is electrochemical, then some mechanical, right. Then 4, we taught you some other treatment method that I am going to tell you something else also today. So, this is the main keywords that I taught, the pre-treatment and the aging effect and how to tune electrocatalytic activity. So, let us summarize. So, dependence of electrocatalytic activities on tuning method. So, whatever development, whatever catalytic activity we are developing for this simple method we are using, it has some impact on surface roughness, surface electrocatalytic activity, surface contaminations. So, there is some different factors you have to remember when you will investigate all the treatment method on the electrode surface, right. So, first roughness. So, how we can investigate this surface roughness? AFM, AFM study, atomic force microgram, that you have to check. Also, you can check for the nanomaterial case, SEM image you can take, scanning electron microscope image also you can take, you can see the surface. So, this kind of characterization technique you have to follow, and definitely after treatment, before treatment, you have to check their electrocatalytic activity by measuring just by a cyclic voltammogram. Simple electrochemical method, cyclic voltammogram. How will check? So, just before treatment you may measure just like hydrogen peroxide oxidations, or maybe you can measure hydroquinone or benzoquinone oxidation reduction peak or glucose oxidations. So, before treatment you can measure something like this, after maybe pre-treatment you can check it something like this, then check after the tuning protocol, maybe it can be here, maybe it can be here, it can be here. So, that story you can find out. So, one is the surface roughness for surface characterization. Second, you can measure the surface contamination. So, how you can measure the surface contamination? You have to measure XPS study, X-ray photoelectron spectroscopy, that study you have to measure. You may get like in the gold case for example. So, gold peak you can see, right. So, before and after treatment, maybe if their gold peak is changing or not. On second, you can check the carbon peak. So, if there is carbon contaminations or not. So, carbon peak before and after treatment, that carbon peak you can check. You can check the oxygen peak, if there is a change of the oxygen peak or not. If there is a organic stuff present on the surface after treatment, then you can see the carbon and oxygen both maybe can change, right. So, these things also you have to check. So, roughness, contaminations, and anything else you want to check? Just one factor I told you last time, the surface reconstruction. Surface reconstruction. This is just a hypothesis I told you that can happen during the pre-treatment and aging case. Means after the pre-treatment, maybe your surface is highly active, your atoms of the surface is highly active, or they can reconstitute each other before treatment, after treatment. After treatment, they feel some strain, and after the treatment, suppose you are going for phantom treatment, or suppose you are going for aging something effect, then this highly you can go again the reconstructions, maybe it can come to the some lower state, active stage. That's why maybe you are getting lower activity. So that phenomena can be explained by surface reconstructions. Okay, so surface roughness, contaminations, and surface reconstruction. Like this way you can explain. Now, so I can summarize the tuning effect. There is two kind of tuning can be done. One is the increase the catalytic activity and decrease the electrocatalytic activity, right? So increase can be done. So I told you, like electrochemical treatment, like sodium borohydride treatment, like anodic treatment, like cathodic treatment. So these are the, they can help the increase. And decrease electrocatalytic activity means you can go like decrease like aging, or you can go for phantoms treatment, right? So like this way you can decrease the electrocatalytic activity also. So you know the fast catalytic activity, why we need something in the fuel cell, basically we need a highly catalytic active material. In this case you can go for the increase the catalytic activity. Decrease means especially the sensor case, you need the moderate activity. For those case you should know that their signal to background ratio should be high, right? Signal to background ratio. So background current should be minimum. For that we may need to go for the decrease the electrocatalytic activity. So this all the tunes activity that I taught you the last class, like size effect, morphology effect, compositions effect, they're all the treatment, right? There can be the thermal treatment. Now let's come here. Thermal treatments in these cases like flame annealing, electrochemical treatment like anodic, cathodic treatment. Sometimes this kind of treatment is very simpler than the other treatment, like flame annealing or any other complex treatment like piranha. This is also another treatment, that is chemical treatment. You know the mixture, what is the piranha? Piranha is a very strong oxidizing agent. It is the mixture of hydrogen peroxide and sulfuric acid, and this mixture can generate very strong oxidizing species, and you have to be very much careful when you handle these piranha solutions. Immediately it can burn your hands if you touch this piranha solution. So that's why handling this kind of chemical is not easy. Maybe you see, if you have some gold chips and if you clean this surface with piranha, then your surface organic material, that is contaminant, can be removed easily. They can be easily oxidized. Your surface become very active surface. But this handling the piranha is a very dangerous. You have to be very much cautious about this. Highly oxidizing agent there. So that is not much favorable for handling this kind of chemical. That's why we are not giving much importance for this treatment for the catalytic activity, because they are very much complex. Also sometimes because of the highly oxidizing species, they can damage the surface also. You have to very much optimize those treatment methods. So today I am just going to tell you this piranha treatment one. It also can increase the electrocatalytic activity, but you have to be careful. That's why we have to search something new treatment, that is very simple treatment, and that treatment is sodium borohydride treatment, right? Why? This is very simple. Let's make a 10 millimolar solutions and dip your electrode inside this solution, and then you can get it. They are very mild. So that's why this kind of tuning methods is very, very important. So now you can see today again I will let you know some explanations like why this kind of tuning method is very important and why their activity is changing. See, so for the tuning we are using phantom treatments. I already told you their reason why it can enhance the catalytic activity or deactivate the catalytic activity. Mechanical polishing can enhance, but phantom can deactivate the catalytic activity because hydroxyl radical it is generating, right. So this case of treatment like phantom, if you go for the gold nanoparticles, you can see their surface roughness is not that much changing. But if you see the gold disc electrode, just I am summarizing all the treatment factor that I taught, right. Gold disc electrode, you see the surface roughness change. So rapid reductions within a desired short period of time, sometimes we may need. Sometimes we may need the rapidly we want to decrease the electrocatalytic activity. Then which treatment we will use, right? So still you have some scope. Like let's find out something new treatment method. So I am going to tell you there is some other treatment methods also still available, like UV ozone treatment or O2 plasma treatment. If you go for this kind of treatment, plasma treatment, they also can enhance the catalytic activity. But why it can enhance? Because this plasma also can remove this O2 plasma, they also can remove all the organic contaminant from the surface. All the contaminant can be removed by plasma, O2 plasma. So like you have to check your all the electrode chips inside the O2 plasma chamber, in the O2 plasma chamber, then you have to turn on the O2 plasma, then you will see the bluish color, then this O2 plasma will remove all the contaminant. But thing is that you need expensive instrument, you need some some trained persons, and you need some pre-process. These all the things can make the complex your treatment method. Again, the thermal treatment, you may need flame handling, some cautious method you have to use. Piranha treatment is very much cautious, you have to take the precaution, right. There is this kind of drawbacks you have to check properly before going for the other treatment. That is why I am always saying you should go for the simple treatment like the sodium borohydride I taught you. So this treatment is very much easier, and but this treatment again is comparable for other treatment. No, just remember I taught you for the palladium nanoparticles. Palladium nanoparticle case, just after the sodium borohydride, how much, like 3 seconds, can you remember? Then it can improve the catalytic activity. So that is why, and the surface also not much change, surface roughness also not much change, it not damage the surface. So that is why it is very, very simple treatment method. So that is why this kind of treatment method also you can try for your electrode surface electrocatalytic activity changes. So another things I will tell you, for like if you go back here, like all the morphology change that I told you, that also you have to keep in mind. Let us come this process. You know the synthesis of the nanomaterial, like how we can synthesize the nanoparticle. Generally we are using two methods, right? Chemical method and another is the electrodepositions method. Electrodeposition method. I will propose sometime you may think about some new nanoparticle generations, not only the simple the gold nanoparticle, not only the simple palladium nanoparticle or platinum nanoparticle. Let us go for something else. It also can readily improve the activity. Why? See, I told you, no, like gold nanoparticle and palladium nanoparticle. These two nanoparticle we checked with the sodium borohydride activity and we find out palladium is the best. Why not something else, like something alloy type? Why not? You please, we may think or may check, like who are, means today I am just going to give you some new area, some perspective, so that you can think whatever I taught until now. Let's apply this on some application. Who are thinking for start your maybe PhD or maybe higher educations, let's think, like see, like gold nanoparticle here inside the, like your core, and like in the outside you may design or decorate with some other nanoparticle, suppose platinum. Let's check this activity with some other treatment like sodium borohydride treatment. Even you can see the degree of the enhancement, degree of the deactivation. And suppose gold, platinum is a highly expensive material. So, you can go for the inside maybe some one material, outside you can use some expensive material, right? Or you can go for the alloy type. Definitely you can see some change of the electrocatalytic activity. So, this kind of scope I want to give you. You can try to think some new area of the change of the electrocatalytic activity and then use for some sensing applications. Then slowly I will teach you the next class these things for the biosensing application again. You can remember like when we converted like gold to palladium, then you can see that with the sodium borohydride treatment, this activity was so fast and so high, then you can achieve the automolar detection. Why it is possible? Because this nanoparticle behaves something else. So that's why not? Why you should not try something else then? Why you should not try something else tuning factor for the biosensor development? That's I am going to tell you now. See, I am just going back. That's why one by one today. Just I am summarizing. Like you may need to decrease the electrocatalytic activity, right? I told you that deactivations can be done by phantons, but it also kind of the mixture of the different chemical. Why not something other chemical you can try? Like only reported phantons already, like some group already tried on the gold disc electrode, some group already tried on the gold nanoparticle. Let's try in something other nanoparticle also, something other bulk materials also. We can check their activity changes. So this kind of lots of scope we have. Like high catalytic activity, generally we may need we need the fuel cell. So you can try like this kind of enhancement that I taught, that can be useful against the fuel cell. Maybe like you can use like different alloy material, and you can study those material not only for fuel cell. Now let's come to the sensing applications. Now you can say without deactivations also we can, like I told you that for the sensing application we need lower catalytic activity. Why? Because you need lower background current, otherwise signal to background ratio we may not achieve, like reasonable value we may not achieve. But still we can think about without deactivation you can change the certain parameter. You can remember that I taught you like potential application, right? Potential applications. So although you may have your catalytic activity of the electrodes very high, but you can apply the potential in the lower range or near lower range or near 0, right? If you apply the near 0, then you can avoid some side effect like oxygen side effect or some interference spacing that present in your systems like ascorbic acid, uric acid. Those things also you can avoid those factors. So sensing applications tuning can be done without very rigorous treatments also. That you can think. So you have lots of scope, that's why. Okay, so those you should remember. Okay, and thermal treatment case, see, sometimes we are using like different. You have to check like your electrode. If you change the temperature, like 25 degrees Celsius to 37 degrees Celsius. Maybe your sensor activity can be changed. Go to the 90 degrees Celsius, even more than this, your sensor activity can be changed. But how long you can store, that you have to keep in mind. That's why sometimes this thermal treatment we are not giving much importance, because when you increase, then come back to the again the room temperature, because mainly for the sensor development, for the biosensor development, you have to come back to the room temperature, and then you have to fabricate your all the material. But during this aging time, there may be aging factor, right? So that you have to keep in mind. During this aging time, it can impact on the electrocatalytic activity. That you have to remember. Another thing, when we are developing the sensor, generally we prefer the room temperature. Generally we are measuring the all the catalytic activity at 25 degrees Celsius at the room temperature. But sometime your catalytic activity, maybe especially biological activity, is very good at 37 degrees Celsius. So you have to increase. So at the 37 degrees Celsius, maybe how this temperature can affect on the material surface, that also you can do some control experiment. So what is control experiment? Control experiment means, suppose you have the electrode surface at the room temperature 25 degrees Celsius, you can check like on cyclic voltammogram of your sensor surface using some basic material, basic substrate that are using without biosensor modification. Then again increase the temperature 37 degrees Celsius using your basic substrate and check the cyclic voltammogram. So at the 25 and 37, what is the difference of the cyclic voltammogram, current, peak potential, those things you can measure. Even you can increase the different temperature values more than 37, not too much. Basically biosensor case we are not preferring very high temperature. So you can check some control experiment and check the temperature effect, and then apply for the these things actual sensor applications. Those things you should keep in mind. So like this way I am just summarizing you today all the treatment effect, how we can use. So basic things that I just wanted to tell you, that all the pre-treatment method, these things is very important for electrocatalytic activity, but you have to think finally how we can use those for the final applications. And your sensor storage is very important factor, that is called stability, and that is very important for commercialization. Why? Maybe you fabricated one sensor and you have to go for packaging. This is another important, means which systems you are storing the electrodes. You may need to store in the nitrogen environment, right, or in the vacuum condition. And you have to check during this storage conditions if this sensing activity, maybe you got LOD some 10 femtogram per ml, but after the long time storage, maybe 1 month, 2 months, like this, even you have to check longer, are you getting the similar limit of detections or similar sensitivity or not? This is very important factor. If you are not getting similar limit of sensitivity, then your sensor is not reliable. Reliability is very important parameter for the development of the sensor. If your sensor is reliable, you can store for the long time with your proper packaging system, then only you can think about the commercializations of your device. So the things I am summarizing today, that all the things is very important for if you really want to start your own, your own startup, your own company, then people should rely on your device, on your technology. So sensor storing, sensor stability, this is very questions mark nowadays. You can see lots of studies nowadays going on. If you check like cancer detection biosensor, lots of study you will get. But why all they are not in the market? You can see very certain chips are readily available in the market. You see the glucometer, only the device you can see easily available in the market. But some devices, glucometer like devices are available, very expensive, but sometimes they are not also reliable. They cannot give you the proper data. So you cannot go for the longer business with this kind of the product. Who are really thinking about their own business, own startup, they have to very much give the importance to sensor storage. So that's why I told you there is lots of conditions that can impact on your sensor stability, like aging factor, contaminations factor. So why I taught all these conditions to give you this clear picture of the storage of your sensor. So many things can hamper your sensor stability. Okay, that you have to definitely keep in mind. Okay, so that's all today. Thank you very much. Then I will come again this kind of new technology things for enhancement, tuning, and then application for the sensor in the next class. Thank you.